Jérémy Plantier, please join me on stage. He's here. Perfect. Jérémy, you are a principal field application engineer and team leader at Microchip.
Yeah.
And you are
Thank
coming
you.
from France, I believe.
Yes.
Paris?
Yeah, not in Paris, where
Okay.
the sun shines all the time in the
Okay.
south.
Okay. Welcome to CYSAT 24.
Thank
First
you.
time for you?
Yeah, that's the first time. I'm pretty proud to be here
Okay.
and very glad. Thank you for having invited Microchip at the CYSAT. That's the first time for us.
Yeah.
I hope that won't be the last.
No.
So I will push for the next year event.
All right, you got 20 minutes for your presentation, and then we sit down on the blue couch for Q&A.
Okay, thank you. So my name is Jérémy Plantier. Thank you all for attending this last keynote for this wonderful event. So I'm in charge of being a technical interface together with the sales team within Microchip. So we will start directly to just remind people what is Microchip, who is Microchip within the aerospace industry. So Microchip is a main provider in terms of total system solution for embedded systems. So mainly known for microcontrollers, microprocessors, and more in aerospace and defense for FPGAs. But not only all of that, you will see that Microchip is also a huge actor for cybersecurity. So let's move with first landscape. So Microchip is a US company, but we have a lot of different sites within Europe. So that's mainly based on acquisitions. So we have a location in France, in Ireland, in Germany, and also in UK. All of them are R&D team that provide different solutions for aerospace and defense. And we have been played around 35 years within this market. So this is not new for us. And we are also working with for offshore security agency within US and NASA also for the aerospace and defense. So we are the largest today silicon vendor for the aerospace industries. And for example, also NASA chosen us to develop the next coming high-performance computer for the next coming generation of satellites, but also rovers and other tied to mission to Mars projects. So we are well in shape in this area. So our main collaboration are involving all of you guys. So we are proud to have different collaboration with ESA, with NES, with DGA, but also we have full support of different distributors, and we are often involved in the elaboration of different projects, so, such as, for example, Iris Square. So let's make now a turn, 180-degree turn. So now we will make a focus about embedding security within an embedded system. So Microchip is a big actor in cybersecurity because of the different acquisitions you have made on the several last years. And we try to replicate some of those use cases. So not only will work for sure for a space application, but we have already experienced a lot of different use cases. For us, the cybersecurity is not something pragmatic. It's something really dedicated to use cases. And that's why we needed to educate for a long time the customers to understand what was the best trade-off in having a cybersecurity embedded into their application. So for us, the embedded system starts with one point. We are talking about space. We are talking about remote application. For sure, we will talk about secure remote firmware management, how to do this, how to implement from the ground base station up to the satellite. We have also to consider all the different logistic purposes, which is crucial because from start to the end application, every part of the system needs to be monitored, needs to be secured, to be sure that at the end, any backdoors will be closed. We will talk about also interoperability. So any satellite within can come from any countries today. We need to think about interoperabilities also down to the component. We also talk about the secure manufacturing, which is close to the logistic and identity management. For sure, we need to monitor, we need to track every step of the secure I would say, of the manufacturing of the device. And then we will have to implement intercommunications within satellites in a secure way. So today, what are the main weaknesses that we are facing regarding our customers? We spend a lot of time to educate them, to make them understanding from the IoT perspective up to other applications, how to implement security. And we had a huge challenge to make them understanding that this is not so much easier. We have to consider different aspects. The first thing that we observed was that all the design perspectives are very hard to consider. It's very hard to push on our customer to make all the steps here to prevent any security backdoors. And we observed a lot of lack of education in terms of having all the different aspects of the root of change, or of the root of trust. So the root of trust is the basic things that we have to implement from the first component up to the deployment of the full application. We talked about also how to store, how to manage private keys. So for sure, HSMs, secure elements, how do you call it? It doesn't matter. This is the same thing, but we need also to understand that all the customers at their level does not have the same facilities, that doesn't have the same ways to handle that purpose. And for sure, we have also observed a lot of different failure across our customer solutions, letting backdoors open, and this is something that we need to tackle. And last but not least, manufacturing is also need to be, trustable for sure. So if we get back to the roots of the security by talking about a little bit about the pillars of the three fundamentals. So we have to implement those pillars within the most easier thing that could be our HSM, that could be our secure element. That's the basic. We have the authentication, we have the integrity, we have the confidentiality. But in space, how those pillars will remain reliable? We need to consider different aspects also. So this slide is just to let's discuss about what can be the different solution that you are considering, what Microchip as a silicon provider can bring as a solution for you. So we thought about interoperability, robustness. As interoperability means having public algorithm shared together for all the satellites to be able to communicate together. We also need to think about how to provide a secure key storage, because that will be the challenge. As the algorithm will be common, it will be difficult also to leverage from the key storage security. We target different kind of application. We talked about from different projects. We talked about secure telemetry, secure inter-satellite communication. We talked about space station, robotic, and all the different applications that we are used to see now more and more. And we talk about also about the reconfigurable stuff. Once the satellite will be in the orbit, that's a key point to bring to the solution. So in Microchip, the goal is to provide one set of solution within different components. We will talk about the hardware root of trust up to the application layer. I won't go into details for all those steps, but what is the meaning of that? Is that we are able to provide different kind of solution within microcontrollers portfolio, microprocessors, secure element, which is just the standalone solution that you can tie to any other host processor. We are also talking about different wired or wireless connectivity. We're also talking about FPGAs, how to protect the IPs within FPGAs. So, as I've seen so many times during those 2 days, we also have an expert team that is able to provide some advice, and that is making also the thread modeling. This is the first step to do. So what is the thread modeling from a component point of view? So we have to define the system requirements. So here you have an MCU with a bootloader that must be secure for sure. We have different type of communications and within different components. We have external memories, we have the key storage, and we have the communication module. So once we have a full overview of the different risks, we can act and we can propose solution, but it will be up to the customer to neglect some part of the solution, to admit that there is a failure, compare the trade-off that he wants to, I would say, that he wants to block. This is up to the customer to have a good idea of what is the level of the security that he wants to reach. Once we have identified things, we are able to identify where we can provide things, where we can provide protections. And at the end, we have defined our threat modeling, but at Microchip we call it a use case, because this is, I think, the most relevant approach to provide a real solution to a real environment of the customer. So here, this is a slide just to let you know that, I guess you already know that, but we have two different ways that can work together or independently. On the left-hand side, you will have a secure element-based solution that is actually a host microcontroller, which is directly linked to I would say, a secure element, an HSM device. All the different commands are sent using a crypto authentication library. So this is something that Microchip can provide also. And this secure element embeds all the different security requirements, security feature already inside it. You don't have to think about microcontroller having a bunch of security feature that will represent a cost at the end. You can just go with this secure element. And on the other hand, we have also today more and more, thanks to major, I would say, core manufacturers, such as a Cortex-M manufacturer. We have the Trusted Executed Environment, which is a TEE. So this will be able to enable two different worlds in terms of security directly inside the chip. So we will be able to leverage what kind of application I want to go without any security, and what are the trusted tasks I want to execute within a secure world. So this can be done under operating system or directly within a bare metal application. All our solutions are common criteria based. So you already know what are the main attack, the most popular attack. So this is just a slide that we already embed all the different pre-certification within our secure element that makes you able to put any kind of risk in front of our device. I mean, any kind. This is up to now under having a use case that is proven as reliable. Just to let you know also, we have, so this is based on our 32-bit MPU portfolio. We have different kind of security and different granularity within our portfolio. From the very first, we have only secure bootloader, and as soon as I go to the right-hand side, I will add another feature that makes your security pretty much more proven. I always compare the security to the housekeeper, for example, system. This is how much you put on your bench, on your table, to simply make the hacker to give up all process because it's too much complicated. And as soon as you will add a layer of security, as soon as the hacker will have to add time and money. And to finish for the microchip overview, this is the portfolio. So I've talked about microcontrollers, FPGAs, but this is not only the part we have. We have a power solution, we have analog mixed signal component, we have timing solutions. So if you have some project, do not hesitate to involve us. We have, I think, the good solution for you. So to finish, the space application today, okay, this is something very particular, something very different compared that we have been experienced so far. But we have a good experience that we can level up to space application. I'm pretty sure that the criticality is quite different, but we have to consider many stages of the application, many stages of the process of the deployment, because all those sides, whatever it's, if it's a ground, if it's on orbit, all the different and both sides will be impacted. So the goal here is to present you a mix between a hardware and a software solution that could be considered for your application with high integrity security and a good level of expertise. So from many years, as Microchip already hold a good leadership in the aerospace and defense industries, we are now more and more targeting all the different aspects of those constraints. So security is one of them, and we are more and more thinking about putting secure element into the space. So do not hesitate to contact us, and I really appreciated this moment with you. So if you have any question, thank you very much.
Thanks a lot, Jeremy. Please have a seat on the famous blue couch. All right, thanks a lot for the presentation. I do have quite a few questions for you, and I'm happy to see a hardware manufacturer and software as well at CYSAT. It shows that we are gaining some maturity in security in the space industry. An anecdote that I've been telling many times is that 5 years ago, when I started to get interested into space security and was asking satellite operators, so what do you do about security? And 99% of them were replying, oh, don't worry, we do AES 256. And then it's a lot more complicated than that. As you know, it's all about the trust that you can have in the secrets. And I believe this is the challenge you are addressing and tackling with your solutions. That being said, this mix of hardware and software based on secure elements is very interesting because it reaches a trade-off which is kind of in between the old space with dedicated production lines, really legacy equipment that we've seen with huge crypto units as big as a fridge. And on the other hand, the full software solution that we see sometimes on the modern new space CubeSat platforms. So that kind of fits in the middle, I understand. And my question is for you is, what market segments in terms of business are you targeting with these solutions?
So actually today we are really present in automotive market for now. And most of our different, I would say, security and safety also progress was based on the automotive market, which is quite constrained because for its obvious constraint and environment. But today we are more and more looking up, and this is something that we are going to invest in. So the space for sure. Microchip has acquired a big company which is Microsemi, that was a good actor and high actor in military and also aerospace, where we will continue all those products within our FPGA and so on. But we will also provide more and more microcontrollers, embedding securities, embedding features that need to be considered for, let's say, something like firmware updates, so dual bank microcontrollers, with also HSM, something like this, directly on the die.
For the space market, are you targeting specifically the commercial market, the really,
sure,
or more defense, or where exactly do you aim?
Yeah, in terms of security, the automotive wasn't the only one. So for sure, the consumers and all the different markets that are tied to protecting data, sensitive data, personal data. So this kind of product can be in any kind of application. I mean, the secure element is very popular.
I'm personally very convinced that we can be inspired and we can learn a lot from the lessons learned from the terrestrial markets, automotive, of course, and also
exactly.
the IoT. They've been through a lot of security challenges in the last couple of years, and space can really take advantage of these solutions. I understand this is from automotive, and is it also part of the IoT, or is it the same thing, security for embedded systems?
Absolutely. Actually, the goal for Microchip is to, well, I've listened so many presentations, and one guy said that from the Space CYSAT panel, he said we need to collaborate. So this is a good, I think, perspective for every actors of different domains, whatever, if it's semiconductor or different application stuff. But we need to collaborate, and the goal for Microchip is definitely to leverage the experience we got from different markets to level up to the aerospace industries.
And then the burning question when we try to spin in technologies from terrestrial applications to the space is that space is obviously a very difficult, constrained environment because of the radiations, the temperature, you name it. It's a nightmare for the electronics.
Exactly.
Where do you stand in terms of technology readiness level? You mentioned you were working with the CNES or other space agencies. Can you explain us, I don't know, what you've been up to so far to qualify or test these products?
So just to clearly answer your question, we have a dedicated team located in Nantes, in France, who is in charge to develop all the radiation tests. We have good expertise on it. So I think that's pretty much why we are also involved with the most, I would say, the most important European project.
Which project can you name somewhere?
IA Square, OneWeb, at the time OneWeb, but not also European project, but also US project.
Okay. So you're currently testing the products, radiation testing on ground, and to make sure I understand correctly, these haven't flown yet on actual missions.
Exactly. We have all the space qualification that are required, and we are able to certify our radiation rate, immunity, on different aspects of what kind of failure we can be exposed to on space application. So that will also let's say drive us to complete our expertise for cybersecurity in space, definitely.
So your call, we had lots of speakers mentioning that they were looking for staff, recruiting people, but you're actually more looking for partners to test your technology in space. You're more looking for satellite operators to launch and demonstrate in orbit the technology. Very well. In terms of of performances, because when pitching hardware solutions to space engineers, the first questions they have is that how much power, how much energy consumption, how much processing your chip is going to take to my OBC, onboard computer.
Yeah.
Do you have any metrics or any information you can give us to convince the system engineers that this is a good trade-off?
Yeah, actually, for sure, the power consumption is very important. But this is we don't actually we put something that we already qualified for different markets with pretty much more constraints sometimes in terms of power consumption. So we have a good knowledge about how to master it. But space is definitely different. We need to constantly have inputs coming from our customer and major actors. This is definitely something that we have to drive together.
All right, and in terms, if I go back to the security topic, again, there are lots of discussions about quantum threats and so on. Is there any crypto agility in these products for you to embark, integrate new algorithms, or have some sort of flexibility?
Yes, definitely. We have some guys who are thinking about. So for the post-quantum algorithm, we already know what can be proposed, but we are still investigating because this is a long-term view. This is something that we need to consider in a long-term view. Yeah.
All right. Personally exhausted the list of questions I had when you talk.
Sorry.
I do get one on the app. Thanks a lot. I'll try to put it on the screen. Let's see if I can do that. Technology. No, it's not working. I'm going to read it out. Oh, yes, here we go. From Satyajit. What is your experience in operating in a zero trust environment? That's a good question. In the supply chain with several tiers of suppliers, how do you make sure that the hardware is doing what it's supposed to do, not doing what it should not, while still respecting the confidentiality requirements? Good one.
Very good question. Thank you. So actually, to answer that, we have kind of commercial offer that targets different kind of customer. We have, I would say, newbies in security customers that want just to put security directly in their application without having all the full picture and the full knowledge about security stuff. So we are able also to handle people who are fully aware of what kind of security level they want to implement in their application. And right in the middle, we have something who could be a mix. So this kind of, I would say, tool for different customer can, we put a lot of effort of having a full control of how we distribute the different certificates, different keys, how to provision. We also provide, we have our facilities which are security proven regarding different certification and standard in security, such as FIPS, such as NIST, such as also all the different variation of the common criteria. So we have this kind of in-house tool.
Yeah, because these problems, again, they've been faced by automotive 10 years ago.
Exactly.
They found some really robust solutions.
Yeah.
Maybe one topic we did not touch was key provisioning.
Yep.
I don't know. Can you comment if you have?
Actually, yeah, we have a key provisioning tool that is directly offered within our factory with a high level of secure module in-house. We need to define exactly what is the secure level that the customer wants to reach, and according to that, we are able to provide the keys directly out of the file. So the customer will receive the secure part directly programmed, and we will send it through a iSecure channel all the certification and the manifest file that it will need to deploy to, let's say, unlock locally the application.
Yeah, in my experience, key provisioning is often a big miss from satellite operators, or sending people to the launch pad, usually interns, because it's a very dangerous job. So this is the end of the event. I have one last question actually for you, Jeremy. I understand some of these solutions does not necessarily require hardware. I'm thinking about TEE, Trusted Execution Environments, that can be offered from the main CPU, some modern ARM cores. Do you confirm that?
So yes and no. Actually, yeah, we have what we call the trust zone, which is provided by ARM within their core license. So we are used to understand now how it could be deployed and how we need to consider to deploy this kind of trusted executed environment. But in the other hand, this is pretty much more related to a feature set. A secure feature set, which is already on the component. Trust zone it was perceived to a must-have. This is my own opinion. A must-have to leverage a good security feature. But from my perspective, this is not really true because we have a lot of different core now, such as the RISC-V. That is coming more and more popular today. That is able also to offer different kind of level of protection, similar to Trust Zone.
All right, I believe this is the end. Thank you so much, Jeremy. A big round of applause for Jeremy Plantier. Thank you, Mike from Microchip.
Thank you.
Pleasure to have you at CYSAT. See you next year.
Thank you very much.